All right, today we're going to look at how to divide rational expressions. And you already know how to do this. If we were asked to divide 2/3 by 12/27, we would change the division to multiplication and take the reciprocal of the divisor. Then we could use our rules for multiplying fractions. And here we could completely factor, as we usually do, the numerator and denominator. So this is just 3 times 3 times 3 over 3 times 2 times 2. Divide through. Okay, so I should color code these. It doesn't matter which pair you divide through, as long as we're consistent. And the answer here is just 3/2. All right. Well, now, before we go into rational expressions whose numerator and denominators are polynomials, let's prove this. Let's prove that A over B divided by C over D is equal to A over B times D over C, where, now the restrictions for the variables are trickier. These denominators cannot be 0, BD, as well as C. So the numerator of the divisor cannot equal 0 of the original division problem. Okay, so these are all not equal to 0. So an easy way to prove this is the following. We'll start with the left-hand side. And every division problem could be written as a fraction. For instance, if I write 8 divided by 2, I could think of this as 8 over 2. So A over B divided by C over D, I'll think of it as A over B all over C over D. This is called a complex fraction, where the numerators and denominators of the fraction are fractions themselves. All right, now, what we'll do is we're going to multiply this big complex fraction by a form of 1. Okay, so let me just write my 1 here, which I love to do, as you all know. And 1 is the multiplicative identity, so we don't change the value of this fraction. We're going to multiply the top and bottom. Well, can you guess what it would be if we want to prove this result? It would be D over C divided by D over C. And we're allowed to do that because D and C are not equal to 0. So we know that we don't have a 0 over 0. So using the rules for multiplication, this becomes A over B times D over C, all divided by C over D times D over C. You can see that these are reciprocals and they divide through to 1 and 1. And the product of a number and its reciprocal is always 1. So we're left with A over B times D over C all over 1 over 1, which is just 1. And any number divided by itself is equal to itself. And that completes the proof. Notice we began with this statement, and using the same statement and a little bit of the multiplicative identity, we got to the final result. This is why we divide fractions this way. All right, now let's get to our rational expressions. All right, let's consider this next problem. Y squared minus 25 over 2 minus 2y divided by y squared plus 10y plus 25 over y squared plus 4y minus 5. All right. So, I find my students like to factor and flip the divisor at the same time. I'll leave that totally up to you. So we could start factoring here. we could factor the y squared minus 25 into y plus 5 times y minus 5. We could factor out a 2 in the denominator here, and we get 2 times 1 minus y. And we change this to multiplication. Now we factor y squared plus 4y minus 5, which is just a plus 5 minus 1. And we factor this numerator, which is y plus 5 times y plus 5. Now, it would be worth the trouble writing the restrictions for the variable. So y cannot equal 1, negative 5, if we look at these denominators. But we should also look at these too, because they were denominators, which is negative 5 again and 1. So we're lucky. We have just 1 and negative 5. Now we divide through. So the 1 minus y and the y minus 1 divide through to a negative 1. The y plus 5s automatically divide through. These y plus 5s divide through. So we're left with an answer of negative 1 times y minus 5, all divided by 2. But again, these are the restrictions. All right, so let's just summarize how we divide rational expressions. To divide rational expressions, we use the theorem that a over b divided by c over d equals a over b times d over c. Write the restrictions by setting the expressions b, d, and c not equal to 0. And then from here, we could just follow the rules for multiplication. And when we do the multiplication part, we have to completely factor and divide through. So the rules still apply. All right, let's try one by ourselves. Now, what would we do when we would have multiplication and division all in one problem? Well, the logical thing to do is to change everything into multiplication. So we have a squared b plus b over 3a squared minus 4a minus 20 times a squared plus 5a over 2a squared plus 11a plus 5 times 6a squared minus 17a minus 10 over ab squared. And then we would try to simplify. So pause the video and see what you come up with. Okay, so in the first one, we could factor out a b, so we get a squared plus 1. The second one factors into 3a and a, so 2 factors of 20. Let's see now. We have 10 and 2, and if we want the factor to be negative, we would negate this one and add this. Let's just make sure that's right. Negative 10a plus 6a is negative 4a. Okay, in the second one, we factor out an a, so that's a plus 5. And this one can be factored into 2a and a. And let's see. So 2 factors of 5 that add up, that would make this 11 would be 5 and 1, because we have a 1a and a 10a makes 11a. And the last one, we have to factor 6a squared minus 17a minus 10. Now this one was tricky. So we multiply the 6 by the negative 10, we get negative 60. And 2 factors of negative 60 that add up to negative 17 would be negative 20 and positive 3. I thought that was tricky. So we have 6a squared minus 20a plus 3a minus 10. And we factor by grouping. So we could take out from these two a 2a, and we get 3a minus 10. And from here, we have 1 times 3a minus 10. So this factors into 2a plus 1 times 3a minus 10. And we'll put that up here. And the ab squared is just a times b times b. I could write it this way. Now we divide through. And when we divide through, notice that these a plus 5 stand out, so that gives us a 1 there. The 3a minus 10s divide through from the last and the first. Let's see. The a here divides with this a here, and this b divides with that b there. And is there anything else? Yes. The 2a plus 1 divides through with the 2a plus 1. And I think that's it. So our final answer would be, multiplying everything in the numerator, a squared plus 1 divided by, and the only thing left in the denominator is a b times an a plus 2. And notice I did not distribute. This is the answer in simplest form. And again, we should write the restrictions of the variable. So we have to look at all the denominators and the numerator of the last fraction. So looking at the denominators, a cannot equal 10/3 from 3a minus 10 equals 0, negative 2 from a plus 2 equals 0, negative a half from 2a plus 1 equals 0, negative 5 from a plus 5 equals 0, a cannot be 0, b cannot be 0, and we have to look at the numerator of the last fraction. When 2a plus 1 equals 0, a is negative a half, so that's good. And when 3a minus 10 equals 0, a equals 10/3, which is good. So these are the restrictions on the variables. Okay, that takes care of dividing rational expressions, and I'd like you to do all the problems in this same way. All right, have a great day. Bye.